students, so already we have started chapter 1, that is the chemical reactions and the equations. So in the part 1 already we have studied the types of the chemical reactions, and in the part 1 we have studied the 5 types of chemical reaction. So in this part 2 we will be studying the some more types of chemical reactions. So already we have studied the combination reaction, decomposition reaction, displacement reaction, double displacement reaction, and the precipitation. Okay, so the number 6 types of chemical reaction, it is called exothermic reaction. It is also a type of chemical reaction. Exothermic, the thermic word, it is related to the heat. So in this reaction what will happen, when the products will be formed, when the reactants will combine and they will form the product, along with the formation of the product, some amount of heat will be released. So what we can say, in this reaction the formation of the product is accompanied by the evolution of gas. So it is a type of chemical reaction where the formation of product is accompanied by the evolution of heat. Example, when the magnesium reacts with the oxygen, it forms magnesium oxide, and along with the formation of this magnesium oxide, some amount of heat will be released. So whenever in a reaction, after the completion of the reaction, if there is the generation of the heat, it is an example of the exothermic reaction. For example, in our body the respiration process takes place. The food is broken down into energy in the presence of oxygen. So this is called respiration. So respiration also is an example of the exothermic reaction. So this is the reaction of respiration, C6H12O6, that is the glucose molecule. When the glucose molecule reacts in presence of oxygen, it breaks down into water, carbon dioxide, and energy will be released in the form of heat. So this is the reaction of respiration. So respiration also, it is an example of the exothermic reaction. So why does the respiration is called the exothermic reaction? Because the glucose is broken down into water, carbon dioxide, and along with this water and the carbon dioxide, energy will be released in the form of heat. Then number 7, next type of chemical reaction, it is called endothermic reaction. It's called endothermic reaction. So endothermic reaction, it is just the opposite of the exothermic reaction. In case of exothermic reaction, what we studied, the formation of the product is accompanied by the evolution of heat. But in this reaction, to carry out the reaction, the reactant need heat. So the reactant will absorb the heat and the reactant will be broken down into products. So how can we define the endothermic reaction? It is a type of chemical reaction where the formation of the product is accompanied by the absorption of heat. It is a type of chemical reaction where the formation of product is accompanied by the absorption of heat. So in this type of reaction, the reactant will absorb the heat and the reactant will be converted into products. Example, calcium carbonate. So if we provide the heat to the calcium carbonate, this is the symbol of delta. It means the heat is being provided. So calcium carbonate will absorb the heat and calcium carbonate will be broken down into calcium oxide plus carbon dioxide. So it is an example of the chemical reaction. Here the heat will be absorbed by the reactant and it will be converted into the product. Then the next type of reactions are called oxidation and the reduction. So these oxidation and the reduction also types of chemical reactions, and these two are just opposite of each other. So oxidation, as the name suggests, oxidation means the addition of oxygen to a substance is called oxidation. Addition of oxygen. Addition of oxygen is called oxidation. For example, magnesium plus oxygen. So here you see the oxygen gets added to the magnesium and it will form magnesium oxide. So it is an example of the oxidation reaction. Now the reduction means the addition of hydrogen. The addition of oxygen is called oxidation and the addition of the hydrogen to a substance is called reduction. For example, if I write the example, copper oxide reacts with hydrogen. Here you see the hydrogen gets added to the copper oxide. They will form copper plus 1. Here you see, here oxygen gets added, that is why it is called oxidation. Here the hydrogen gets added, that is why it is called reduction. Now, we can define the oxidation and the reduction in another way. We can say removal of hydrogen from a substance, it is also called oxidation. See, the addition of hydrogen is called reduction, removal of hydrogen is called oxidation. For example, if I write the example, ammonia. Ammonia breaks into nitrogen plus hydrogen gas. So here you see the hydrogen gets removed from the ammonia. So that is why it is called oxidation. And in another way, we can define the reduction as, here you see, the addition of oxygen is called oxidation, the removal of oxygen is called reduction. Removal of oxygen is called reduction. And this, for example, here also we can write. Here you see, the oxygen was there before with copper. Here, see, copper oxide plus hydrogen. It forms copper plus 1. So here you see the oxygen gets removed from the copper. So it is an example of the reduction reaction. Now in nature, whatever reaction takes place, this oxidation or the reduction, they cannot take place alone. Oxidation also does not take place alone. Reduction also does not take place alone. Both oxidation and the reduction processes takes place simultaneously. And whenever this oxidation and the reduction process takes place simultaneously, then these kind of reactions are called redox reactions. Number 10, redox reactions. Or this also can be said as the oxidation reduction reaction. So what is redox reaction? It is a type of chemical reaction where both oxidation and the reduction processes takes place simultaneously. It is a type of chemical reactions where both oxidation and reduction processes takes place simultaneously. So in this type of reaction, oxidation and the reduction takes place at a time. For example, I have written one example: copper oxide reacts with hydrogen gas. So it converts into water plus copper. Here you see, before copper oxide, with copper oxide oxygen was there. Now with copper, here oxygen is not there. So the removal of oxygen is called what? Reduction. So here what process took place? So here the process of reduction took place. But in this case, with hydrogen, oxygen was not there. Here the hydrogen, with hydrogen, oxygen got added. So when the oxygen gets added to a compound, then this reaction is called what? Oxidation. So here you see, in a same reaction, both oxidation and the reduction takes place simultaneously. And always remember, in the nature, whatever the reaction takes place, oxidation and the reduction does not take place alone. Oxidation and the reduction always takes place simultaneously. Here you see, copper oxide, it gets reduced, whereas the hydrogen gets oxidized. So that is why it is an example of the redox reaction. Redox reaction is another name we can say oxidation and the reduction reaction. Now, this oxidation and the reduction in another way also we can define. In terms of their electrons also we can define the oxidation and the reduction. Oxidation and reduction. We can define this oxidation and the reduction in terms of their gain or losing of electrons. So, whenever from any element, if they lose the electrons, see, loss of electrons, it is called oxidation. Whereas the gain of electrons, it is called reduction. For example, if I write magnesium plus oxygen, it will form magnesium oxide. So the atomic number of the magnesium is 12. The electronic configuration is 2, 8, 2. Whereas the atomic number of oxygen is 8. The electronic configuration of oxygen is 2, 6. Here you see, to become stable, the magnesium can donate these outermost 2 electrons and can achieve the octet. In the same way, the oxygen also can accept the 2 electrons to achieve the stability. So in this case, the magnesium what will do? The magnesium will donate the 2 electrons to oxygen, and the oxygen will accept the electrons. So here you see, so what the magnesium does, it has donated the 2 electrons to oxygen. So by donating the 2 electrons, the magnesium became stable, and by accepting the 2 electrons, the oxygen also became stable. So in this way, here you see, both oxidation, before I have written, this is the example of the oxidation. But I told now, the oxidation or the reduction processes cannot take place alone. Here you see, the magnesium donated the electrons and the oxygen accepted the electrons. So what is the definition of oxidation I told? The loss of electrons are called oxidation and the gain of electrons are called reduction. So in this reaction, both gaining and the losing took place simultaneously. So it is also example of the redox reaction. So these are the 10 types of chemical reactions. So try to remember all the types of the chemical reactions along with their examples. Thank you.